Thank you very much for your time and overwhelming support to this activity. I'm a GH Chen, consultant to GHC, not GHG, greenhouse gas, okay? I've been working at this department for 16 years. So I joined this university from National University Singapore back into 16 years ago. After I was brought to see the beautiful campus, I love it, then I joined. Maybe I should say I'm not regretting, okay? Today I will talk about something new, hope that exciting you from something you can learn, something can be done in Hong Kong at HKUST regarding the new concepts of wastewater treatment and two applications. So not only writing paper as a professor, we also make contributions to the society in real sense. What means green? The words we always use green. Green to me means that saving space, reducing cost, reducing energy, while solving problems. You can use sustainable words, smart words, but I use here green. Green means, as an engineering guy, we need to get problem solved efficiently. Okay. Now, we have a lot of problems in our country, China, and particularly we have water environmental challenges in China. Number one, we don't have a lot of water. And we only have 30% of fresh water available to all Chinese, which only 30% of the world average, 2,000. And we don't have water. If no water means no life. No water means to Cantonese, no money. That's the reason we have a lot of business leaders here today. Water is so important. Everybody knows. We can buy energy something, but we cannot buy water. Only in a way you can mention that you can argue, can we claim water from seawater? Yes, we do, like Singapore. But that is very expensive. Burning too much coals, we know. This is a textbook knowledge. But something that we need an innovative idea, we can solve the problem. Actually, Hong Kong, representing a very, very successful experience in solving water shortage problem. I don't know whether you know, we are the worst city in the world in terms of water resources availability. We only have 125, not 2,000, way below China's level. But we solved the problem. We are doing very good. We are even doing much better than Singapore. But you guys don't know. I'll show you later. Okay? We are excellent. We should have confidence. Hong Kong can do excellent work for the world. And at the same time, we have a lot of wastewater produced in our country, in mainland. You can read this number, 571 billion sewage wastewater produced per year. And only 50% are treated. You can think about what the problem is. It's a massive, huge scale problem. Water problem. Why we are lacking water? However, we are discharging too much untreated water. It's a vicious circle, worse to worse. Then the consequences of sludge treatment, wastewater treatment, resulting a byproducts, harmful, unnecessary byproducts. What is it? Sludge. The sludge is a tricky guy. Sludge cannot be easily dumped, recycled, reused freely. Sludge finally has to be burned everywhere. It will be soon in Hong Kong. It already burned in Shanghai, in Guangzhou, to some degrees. But it will be going to very large scale practice. We know the problem. Burning sludge is costly, is energy intensive, and what's end on? Air pollution contamination. Okay? So Now, these are the big problems we are facing now, are the challenges. Then you wonder why this problem cannot be solved. Money is number one, sure, okay? But many times we have constraints of current technologies we have been using for 100 years. What problem we have? Number one, too much sludge produced, accounting for 50% of energy consumption of cost, space. In Hong Kong, we will produce 2,000 tons sludge in a few years later. What is the solution to this sludge? We know EPD will burn sludge. How much is it? According to my calculation, it's about 850 Hong Kong dollars to burn one dry sludge, 1 ton dry sludge. We have to pay it. But it's not sustainable for sure. All right? At the same time, the water treatment part is also too much energy consumed. Electricity used. 0.3 kilowatt for treatment of per cubic of wastewater everywhere in the world. It's too high. That's the reason why we don't have a lot of water treated in our country, because too much energy consumed. All right? And last one is also, again, too much space needed. So we need energy, money, and space all together are necessary to deal with this problem. That's the reason we cannot solve these challenges very efficiently. Here we're presenting you a HKUST innovation of new technology. I just remember the name, called SANI. I can tell you where's the name from. SNI means half words of sanitation. Remember, in Chinese name is called killing sludge killer, sanai, sludge sasai, all right? But it's very powerful. Some people say it's very powerful naming, okay? I think you will remember forever this name, okay, after my talk, hopefully. Now, give you the background of the innovation. What is the sunny technology? What is the beauty of this sunny technology? Okay, look at the history of the development of 100 years biological treatment technology. Biological treatment is the main forms of, main technology of large-scale industry wastewater, domestic wastewater treatment. And the technology was invented by 2 British engineers in 1914, which we use a very simple way, natural way, that we pumping air, oxygen, pumping air to provide oxygen to oxidize organic pollutants, the major pollutants discharged from us, and to convert organic matter into CO2, which we complete the natural cycle. Okay? It's a good idea. But the problem is that the oxygen is hardly dissolving guy. Lot of air pumping inside. In Cantonese, sai here. Only a few percent working. Most of them just sai. Just go through it without doing any contributions. That's the reason it's expensive. Secondly, that this conversion, no matter what you do, only can convert 40% carbon into CO2. The 60% carbon will stay in the form of sludge. So this conversion is not beautiful conversion. Energy intensive is half-baked. But it's a natural reaction we know. We can do it easily in Sati, in everywhere we do it this way. And so technology has been doing everywhere, and we know the problem. And now, by 1962, we have a few professors, they will invent another new thing that we can add on removal of nitrogen, because nitrogen is another major pollutant to our water bodies, causing algae blooming, algae growth, excessive algae growth. So we can aid in this reaction, again, using organic to do a denitrification to back nitrate from ammonia to nitrogen gas. Again, is nitrogen cycle, natural reaction. And this reaction cannot solve the problem because we still use oxygen. And this reaction, again, produces a lot of sludge, as same as the organic oxidation, same. Okay? And now, we invented technology because we know that Hong Kong using seawater to flush our toilets for 50 years already, saving tremendous fresh water, 22%. Every day, 750 cubic meter fresh water saved, much cheaper than Singapore's new water, I'm sure. They are only doing few percent. We are doing 24%. Great engineering success. All right? Because this practice, we realized in 2002, can we do something to fit and to maximize the benefits of seawater toilet flushing and to get green technology developed? Now remember, the benefits of seawater toilet flushing is bringing a lot of sulfate into our sewage, causing problems. We know, smelling problems. This is better side. We want to turn the bad side into good side. Now, the idea is that sulfate can convert organic carbon into CO2 very efficiently. That's the reason we have smelling problem everywhere in sewer, you know. This knowledge has been with us for many years. Of course, you tell me my mother's lady, anything new. The new thing is here that we can convert this sulfate into CO2. Why this H2S won't be produced? No smelling. So the beauty is here. I'll show you later why. And that's a lot of people forgot. So when we're searching the patterns, a little bit the pattern lot, but none of them hook up to the seawater toilet flushing resistant sewage, saline sewage, salty sewage. That then the product is that can utilize as a reaction for denitrification to convert nitrate to nitrogen gas. So we are completing carbon cycle and nitrogen cycle here without being bothered by oxygen. We don't need oxygen. The oxygen here is not from air. You don't need to pump a lot of air. You know what I mean? You solve the problem from the root. And this nitrogen cycle produces almost no sludge. That's good. I'll show you later the reaction equations, okay, something. And that's this nitrogen cycle. So this simple idea, by making use of sulfate originating from toilet flushing practice, and we can turn wastewater treatment into a green process, saving space, saving money, saving energy, and more importantly, we don't need to worry about the sludge anymore. That's a huge impact. Okay, so our news be released. I was told my friend, is 100 Chinese website news sites reported HKUST sunny technology. It's good PR for HKUST. Sure, I think our president will be very happy. Okay, and so this technology will redesign 100 years treatment technology because the concept changed. The concept will change from 2 cycle ideas used for 100 years into 3 cycles. Scientifically, it's new that we're adding this cycle. So everything changed from 2 dimension into 3 dimension. From oxygen here into these 3 cycles. So we're linking this. All the reactions are natural reactions. We don't need to use any special bacteria. They are all natural bacteria, natural biomass. Okay, however, what we do that we can introduce new reactions to realize something new in the practice of wastewater treatment. So this technology we named from the name of long name is sulfate reduction, is autotrophic denitrification, nitrification, integrated process shortened to SUNY. And since happened to be the Chinese name, killing sludge. So very lucky, okay? What we can do in terms application, technology depends from the concept. The concept is okay. Then we can realize we can develop into a system, as a working system, which we can have 3 reactors. Number 1 is a sulfate-based organic conversion on the anaerobic condition, no oxygen. And UASB, a sludge upper flow bed, which is quite common means of treatment. And then after that, we produce the sulfite, and the sulfite will be utilized in reduction of nitrate into nitrogen gas. And then we have this here. So the concept is sulfate from the beginning to sulfate again. And then you worry about any problem, no problem, because sulfate already been with us. We just turn around. We don't produce any harmful byproducts. At the same time, we don't have sludge. We are discharging our wastewater treated water into ocean. No problem, because natural cycle. We have a lot of sulfate in ocean. If you discharge it into freshwater body, then you should watch out the concentration of sulfate. So in toilet flushing areas, no problem. It is a natural cycle. You don't need to jump up, say, oh, any problem. No, no problem. Okay, this technology,